process map with frequencies can still be configured in multiple ways. The default frequency map shown before shows the absolute frequencies of activities and flows. In other words, in this schematic example, activity X was performed n times, and activity X was followed n times by activity Y. Besides the absolute frequencies, we can show three other types of frequencies: relative frequencies, absolute case frequencies, and relative case frequencies. Depending on the different configuration, the interpretation of the numbers shown in the place of n, m, and o will be different. In a relative frequency map, we can say that the activity X represents n% of all activities performed, and the flows between X and Y represent n% of all the flows. In a process map with absolute case frequency, we can derive that activity X was carried out in n cases, and in m cases, activity X was followed by activity Y. Finally, in case that the process map shows relative case frequencies, this means that activity X was performed in n% of the cases, and in n% of the cases, activity X was followed by activity Y. Depending on the questions you want to answer, you can choose for one of these configurations. In addition to the standard absolute frequencies, the case frequencies, both absolute and relative, are particularly interesting. After all, they implicitly calculate the number of times that an object has gone through a particular part of the process, and are therefore often easier to interpret. The second type, showing relative frequencies, is often less interesting. But let's look at some examples. This is the example we saw before, with absolute frequencies indicating how frequent an activity or flow occurs. One activity that is particularly interesting to look at in these and the next examples is the payment. We can see here that there were 4,764 payments. Now, if we change to a process map with case frequencies, we can see that there were only 4,514 cases when a payment was received. As a result, this means that the payment activity occurred more than once for some of the cases. We can see this also by the loop on this activity, which occurred 250 times. If we look at the process map with relative case frequencies, we see that this loop is present in 2.54% of the cases. Furthermore, we see that the payment was only executed in 45.93% of all cases, which is less than half. This example shows us that often it is interesting to take more than just one metric into account when looking at a process map. In Bupa, up to 2 metrics can be added to a single map. In this map, we see both absolute case frequencies as well as relative case frequencies between parentheses. Changing the number shown in the process map can be done in R by changing the parameters of the process map function. In particular, the parameter type can be set to different profile functions. For frequency process map, we use the frequency profile function, where we can set the particular values that we want to show. One of the major drawbacks of process maps is that they can become quite chaotic for unstructured processes because the amount of errors they will attempt to draw between activities. To illustrate this problem, have a look at this process map of the clinical hospital process sepsis. In processes where many activities can be executed in seemingly random orders, the process map will get cluttered very fast. Unfortunately, many real-life processes are very unstructured. In the next video, we'll look at some direct alternatives to process maps in order to cope with this problem.